So hello everyone, it's great to be here at the PennApps Hackathon, and I appreciate you guys coming out to hear this talk about flow-based programming. So before I kind of get into the talk, if I could see a raise of hands of how many people have ever heard of flow-based programming before today? Okay, and of those people, how many people have used flow-based programming before? Okay. Overall, how many people have ever used Unix pipes? So, the piping command on the command line. Okay. And this usually gets everyone's hands up. How many people have ever used Microsoft Excel? All right. So, believe it or not, even applications like Microsoft Excel are kind of using flow-based programming, even though you don't really know it, right? Where these various cells can be connected together through formulas, and so when you manipulate one cell, it's triggering the execution of another one. And so some of this will be a little more clear as I go through this talk. So what is flow-based programming? Well, this is a quote that I pulled out of J. Paul Morrison's book, Flow-Based Programming, and it's and Morrison's considered kind of the father of flow-based programming in some circles. And so if I was to kind of paraphrase for him, it's basically a paradigm where developers go and create these components or modules. He's calling them black boxes here, where these components are essentially functions. They do something, and they have inputs and they have outputs. And the idea is that at a later stage in the development cycle of an application, you can join these components together by creating connections between the outputs of one and the inputs of another. And by doing that, you can essentially create more and more varying applications, right? So you can add or remove components and string them together differently to produce a different functionality. So where did flow-based programming come from? Well, it was recognized by Morrison back in the 70s when he was at IBM. And it actually probably predates to even before this. But he was using it actually kind of in a project he was doing for the Bank of Montreal, and they were using to do a lot of their batch processing of mass amounts of transactional data and creating reports for the banks. So they use that to be to kind of add or remove different components in the system, and to be very, very flexible. And it's always fun to hear these stories of how they used a methodology or technology, and to even think that it's still being used 40 years later. This technique actually probably even predates before the 70s, or at least people had ideas of this. And so this is a quote from Douglas McElroy, who said this in a memo to a colleague in the early 60s. And so I'll read this. He says, we should have some ways of coupling programs like garden hoses. Screw in another segment when it becomes necessary to massage the data in another way. This is the way of I/O also. And so I love that analogy to garden hoses. And so people really, really wanted this modular and way of stringing together functionality very, very easily, and allowing more of the end user to actually create this functionality, as opposed to always the developer really determining how everything should be executed. So what are some advantages to using flow-based programming? Well, in this talk, I'm saying that you can create quick apps using it. Well, what do I mean by quick apps? Well, there's kind of two ways of using the word quick here. One is for fast development time. So you can basically take someone else's components and create a higher level application very, very quickly because those things already exist. The other thing is runtime. You can actually develop much faster applications in terms of runtime by using flow-based programming. And this is because the components are isolated and they can run in parallel with each other. And I'll get into a minute of why that is so useful. The other thing is that by kind of buying into this way of developing apps, you're essentially creating this pluggable and reusable architecture where you can add or remove components very, very easily. And it also creates a testable system right off the bat, right? So these components can be stood up. You can stub out some test inputs and verify the outputs of each component, and then join a few together, test that, and start to build up your system like that. So it's very, very nice to test the atomic elements before creating this massive system. The other thing that this technique really provides is that you can carry the structured analysis into the execution phase. So what do I mean by that? When we're initially creating large software architectures, we start at the whiteboard with some colleagues and we draw our component diagrams, which are, the components are going to be blocks, and we're going to draw arrows between them, say, oh yeah, that one's going to communicate with that one, it's going to send these messages. It needs to alert this one, it's going to receive information from here. And then, we look at that and then we start actually coding. And so the connection between that blueprint and what we've actually developed and what we're actually executing is kind of lost. I mean, it's not really lost, it's kind of in our heads, or it's in PowerPoints and Word documents, but there's no true linkage between the design and the actual execution. But with flow-based programming, you're actually executing the blueprint, or how these things are actually connected together, which is really, really nice. One of the key takeaways of flow-based programming is that when you're creating these, you're actually defining dependencies between the modules, as opposed to defining the execution order. So when we're typically coding, right, we're executing instructions one after another, and these lines of code are basically communicating with shared state, right? They're manipulating variables that they're sharing together. But with flow-based programming, these modules or these components are connected together, and so one component may depend, its inputs may depend on other components. Okay, and so this is actually very similar to how build systems work, like Maven or MS Build, where whether you're creating a jar or a DLL or what have you, this project has dependencies, right? It has references to other projects that it requires. And so when you're building this, you don't normally define the execution order, but you just say, okay, this project depends on this one, and that one depends on this one, and the build system figures out what the optimal order should be to execute or to build all of your components. And what this allows the system to do is actually parallelize the build process, right? You can actually build many things in parallel. And so by defining your dependencies and not your execution order in flow-based programming, all these components can be executing in parallel, which is absolutely fantastic. The other thing that it really buys us is end-user behavior modification. So as a developer, you don't have to think of all of the use cases or all the possibilities that someone may want to do with an application. Those things can actually be modified at a later date very, very easily by an end user. And this is kind of tied to that there's always these unanticipated needs or requirements that come up, right? And typically, there might be a requirement that just the software is not capable of doing. But by using flow-based programming and by allowing the end user or another developer to manipulate it very, very easily and quickly, you can accommodate these unanticipated needs. So I kind of like to call this just-in-time coding. So Microsoft has the concept of just-in-time debugging. So if there's a break or a fault in a application, right, you can immediately break there and start to debug the application. Well, in just-in-time decoding, if an unanticipated needs arise, you can begin to start to modify the application, begin to code very, very quickly to meet that new requirement. So there's lots and lots of existing frameworks out there that leverage flow-based programming. Microsoft Robotics Studio is a great example where people can go and use this technique to control their robots. So right, you might be sending commands to turn the wheels or raise an arm on a robot, or you might be getting inputs off a remote control, and you need to then send those to a controller. LabVIEW is another great example where you're getting information off sensors, sending the stuff to microcontrollers or to displays. And there's lots of commercial products out there, and some frameworks well. So Yahoo Pipes is actually a really well-known one. It has really gained a lot of traction in the last 10 years, and it's a great way to mash up various RSS feeds. Pipeline Pilot is great for chemists and biologists who are analyzing lots and lots of data. NoFlow is another one. It's purely JavaScript, but you can also use it on the back end using Node.js as well. And Blocky.io is really recently gaining a lot of traction, and its creator has coined it, saying that it's forest made. And this is just a great story where he's actually from Sweden, and so for a year he went out just in the forest with a 3G connection from some solar cells in his laptop, and he created this great flow-based programming framework. So if you have a chance, check it out. And a lot of this, some of the big boys are actually getting involved in this as well. So Google has kind of announced that it's ditching Hadoop and going to a more data flow-based methodology of processing massive amounts of data, right? And they're essentially using flow-based programming in that. So there's lots and lots of examples, but they're actually the execution engines that underlie all of these are usually slightly different. So some are more stream-based, where they're taking in just characters off standard in, or some are more object-oriented, where the information that's flowing between these components are actual objects. They might be tables or integers or strings, but they have more structure to them. And the decision of when these components should execute varies across all these different frameworks too, right? So some might say, okay, all of the inputs that are feeding into an input have to all be satisfied before it will execute this one. Where other frameworks say, okay, well, if any of the inputs have been satisfied, then I'm going to execute that component. And this is tied to how state is managed within the application. Right? So some say, okay, the components are going to be stateful. So as information is feeding into it, they have to maintain their own state. You get a new variable coming in, but one of the other inputs you haven't received it yet. Well, you got to use the old one, right? So you have to maintain that. Whereas other ones say, okay, the components are completely stateless. I will give you all of your state at once. You do what you need to do, and then the next time I'll call you with all the necessary information again. But kind of the key takeaway too, though, is that all of these frameworks or products, are similar as well, right? Their programs all consist of components, and you connect the inputs and outputs of them through essentially connections at a later date. So whether you're creating your own Flowbased programming kind of framework or creating your own modules within one, how do you know that you've kind of hit the sweet spot, right? Because you can kind of go down this road and it may not be the right fit. Well, kind of the first rule that I think of is that the modules that you're developing that are going to be strung together later, they need to be atomic yet high level at the same time. And I know this may sound contradictory, but if you kind of choose and scope your domain correctly, this can happen, right? So if our domain was, say, like tabular data integration, some of our modules are going to be filtering, some of them are going to be joining, some of them are going to be aggregating. And so these are high level concepts, but these are kind of atomic operations on that particular data set. The other thing is that you want to give enough flexibility to another user, but the application should be easy to create, right? So you don't want modules that are literally one line of code, because that would just be insane to try and create an application using Flowbased programming for that. But you don't want them to be these absolutely massive monolithic modules, because then you're not going to be able to create as many diverse applications, right? The module is going to be easy to use, but you're not going to be able to do much with it, right? Because it's going to be having lots and lots of functionality built into it, and so you really need to kind of decompose those massive modules down to smaller items. But this brings up a good point, right? Decomposing your application into kind of these smaller functions is a hard problem, right? As developers, we struggle with this day in and day out. But if we kind of take this cost and just assume that's going to be a little more difficult to decompose the problem at first, it's going to allow for a tremendous amount of variation later on, and applications are going to get more and more easy to create. So how do you know that you've succeeded with Flowbased programming? Well, for one, the time to create a new application should be small, right? So if it's taking you more time to create the app than it would, just writing it all in code, without many other frameworks, then we've got an issue there. Also, the number of applications is that you can actually develop with your palette of modules is a good factor and a key metric to look at, right? So if you can only develop a few modules, then one is your mod for applications, your modules might be too big, or you may just not have enough of them. And I think probably one of the key metrics is that once you develop this palette of modules and you've got some apps in there, is if another user comes along and creates an application that you never thought was possible, I think that's kind of the key metric. So let me switch gears and talk about a framework platform that we've developed at MIT, and it's called Composable Analytics. And it's essentially an environment that allows users, whether they're developers or analysts, to explore, create, and collaborate on analytical methods and reporting applications. So these applications are essentially flow-based programs that allow you to query and fetch for information from a wide variety of sources, whether it's relational databases, web services, spreadsheets, and aggregate, mash that information together and produce results. And results might be charts, tabular data, JSON or XML blobs, and you can then send that information off. So you might be inserting data into another system or database, or you might be presenting a KML file, or maybe you're just sending out an email. But really the system allows you to find other individuals or groups that have common interests and leverage their prior work. So you can basically take someone else's application and use it wholesale, or modify it to suit your needs, or create an application from scratch right in the web-based designer. And kind of the most important feature is this ability to collaborate, this ability to share your results through boards, and share your apps so that other people can reap the benefits. So really at the heart, you can kind of think of Composable Analytics as this integration platform for data and processes. Its execution is essentially using flow-based programming. So these modules, as I said, they might be querying databases, they might be executing MATLAB code, and people go and string these together. So these modules have inputs and outputs, and they're strongly typed. So you can only connect certain ones to other modules, and this really allows for essentially an infinitely configurable system, because you can always add new modules into it, and you're never really in this position where you're stuck, where you can't do much and you've got to go use another system. With leveraging flow-based programming, your users can always extend and augment the system however they need. And the other great benefit to Composable Analytics is that it's providing this marketplace for analytics, right? So you're leveraging these applications that someone else has developed, right? So they took the atomic building blocks, they created a higher level, essentially building block that someone else can then use. So within the environment, there's various levels of flexibility depending on the capabilities that are used. So kind of your more novice users are basically going to go there and really just reuse someone else's application, right? They're not going to modify it. They're not even going to probably open the designer, but they're just going to modify input parameters there. And then as we go kind of down the stack, really the user requires more technical ability, but these capabilities are less easy to use, right? So the next one would be referencing another user's app within the application, right? So now you're actually building a new application. Kind of the next one down the line, if you need it, or if that app doesn't suit your needs, you need to take that application and start to modify it. So you're actually going to begin to modify the guts of the application. If you can't find anything right, you need to create your own application. Now here we're really talking about developers or very analysts that have a lot of programming skills. But you're really limited to the modules in your palette. So what do you do if there's some needed functionality that just doesn't exist in your library? Well, we actually offer this this thing called the code module, where it literally allows you to stick in any code that you want. Granted, we sandbox it so you can't do absolutely everything, like look at the file system or make network calls, but it really allows you to really extend the system very, very easily. But maybe you actually need to modify how someone's interacting with this module, whether it's the input controls or the rendering. Well, in that case, okay, you need to write what we call a first-class module in the system and register it. So talking about these first-class modules, when you're going out and developing one of these, there's basically 4 extensibility points for the module. The first is the actual type system. So this is defining the inputs and output types of your module, and these types are actually shared across all modules, right? So some of the more atomic types might be integers or strings or booleans, and some of the more high-level ones might be charts or tables or lists, or it might just be an object. So we support inheritance, right? So if one module is taking in an object, well, you could pretty much feed anything into it, right? Whether it's a string, a boolean, a table, or a list. And the other thing that we provide, or at least leverage, in this type of system is conversion. So if the output of one module is an integer, but one is accepting a string, well, the integer is convertible to a string, so we'll go ahead and automatically convert that for you, so that your applications are not littered with massive amounts of just conversion modules. The biggest extensibility point is the actual execution routines within the modules. Right, this is where you're actually going to get the inputs. The module is going to do what it wants to do, and then it's going to set its outputs. And not all inputs have to actually come from connections. So modules can define input controls, and these are a way for the designer to set the actual value. So they're almost hard coding the input there. And we see this a lot in application development within Composable Analytics. And then finally, the last extensibility point is the rendering or the visualization of your outputs. So whether it's charts or JSON data or tabular data, you can register some JavaScript code to visualize those outputs. So the input controls and the output rendering are both in JavaScript. Alright, so let's jump into a demo. Alright, so this is the Composable Analytics interface. So when a user first logs in, they're presented with kind of their main dashboard where they can quickly get at the various entities in the system, whether they're applications or boards or groups. And so if someone was to basically go and in need of an application, they can try and basically discover the application through our interface. So here you're basically getting thumbnails, previews of the various applications. So let me just kind of show you how easy it is for someone to create an application. So I'll start with one that I've barely started here. So here's one that has a module. This is running an ODBC query, so it's going out to a database. This one, for example, is looking at hospital visits. So here we've just kind of plugged in a very simple query. So we're actually doing a group by, an account here. So we're counting the number of visits by each age. You can see that when I run it, we're going out, recurring, millions of records, and very, very quickly we can get back our results here. So we're seeing, the age and the number of visits. And let's say we want to plot that and then disseminate that information out. So I will look under my visualizers, make this a little smaller, and grab the chart module, and I will plot, age on the x-axis, and I'm going to plot the number of visits, so I'll just call it the number of sick. And if I was to run this, here we can see our chart, and you can see that actually, as people get older and older, the number of visits is going down. So you might be wondering, well, why this is. Well, it's in fact because, as people getting older and older, there's actually not as many of them, right? Because people are dying off, and so there's not as many visits. So if we were to, another way to look at this data is, well, let's try and baseline this data and look at the rate of visits based on population. So one thing that I can do is I can do a search for another application that I've created, and this one's basically taking in basically a location and it's returning a table. So let's go ahead and run that and take a look at its output. And so here we can see that I'm looking for each age group the population within Massachusetts. And we can take a look at this app here, right? So if I crack this open, I can see, okay, it's actually going out to the census.gov site and grabbing that data, and it looks like it's actually doing a filter by that location. So let's go ahead and baseline the number of visits here, and I'll basically take our table scalar module, and I'll pipe in the value table here and our scaling table here, and I'll choose the visits for our value column, and we're going to join by age, so we need to join these two columns together. And I'm going to divide the visits by the population. So if I was to run that again, here I can see that now I have the baseline number here. So rather than plotting that, I'm going to plot this table, and I'm going to plot this column. And now you can see that number is actually going up. So let's not stop there. Let's say we want to actually disseminate this chart. So I'm going to take this chart, I'm going to convert it to a JPEG, and then I'm going to email it out. So I'll grab that JPEG and I'll add it as an attachment. And the other thing that we can do is that we don't just have to email it to someone, but we can also send that to Facebook as well, right? So here I'm actually taking that JPEG, I'm adding as an attachment and a photo, and I'm actually going to click this parallelize button. And what that's going to allow me to do is actually execute this query and this query in parallel, and you can see that these ones are going to be blocking on those, but it's going to allow me to send the email and send or post this JPEG to Facebook asynchronously. I'll just give it a message and I'll run that. And so if I was to go to Facebook, here you can see that we now have our chart posted to Facebook. So in just a couple of minutes, we went all the way from a database, a health database. We pulled in data from the census, we aggregated it, we created a chart, and we then disseminated it to two different destinations. Right, so we can go all the way from a database to Facebook, very, very easily. And so with that, I will turn it over to questions. And just to kind of give you guys a heads up, if you're looking to use this, we have a demonstration site out there. You can just Google Composable Analytics and find it. We also you can download an installer and have your own instance. So if you use Google Composable Analytics, there'll be a try it button and a download it button. And so yeah, you can begin to play around with it. So any questions?